Have you ever wondered why the universe exists as it does and how it came into being? The enigma of the universe is a question that has fascinated humanity since we first looked up at the night sky. Let's dive into this mystery together. Imagine this. Everything we know, everything we see, the entire cosmos was once condensed into a single point of infinite density and temperature known as a singularity. This is the core idea behind the Big Bang Theory, the leading explanation about how the universe began. Approximately 13.8 billion years ago, this singularity started expanding in a hot fireball of particles. This wasn't an explosion in the traditional sense, but rather an expansion of space itself. Imagine a balloon inflating and on its surface galaxies drifting apart. That's akin to what the early universe was like. In the first few moments, the universe was too hot and dense for particles to form anything. But as it expanded, it cooled. Particles began to combine, forming atoms, then stars, and ultimately galaxies. The universe as we know it started taking shape. But here's the twist in the tale. The universe is still expanding. Yes, you heard it right. Astronomers have found that galaxies are moving away from us in all directions. This means our universe is not only big, but it's getting bigger every second. This expansion is one of the toughest concepts to wrap our heads around. We're talking about an event so colossal that it's beyond human comprehension. It's like trying to imagine a number larger than infinity, yet it's this very concept that has shaped our understanding of the cosmos. And so we come back to our original question. The universe, in all its vastness and complexity, was born from a singularity in an event we call the Big Bang. An explosion of such magnitude that gave birth to the cosmos, and it's still growing. Isn't that mind-boggling? Imagine vast cosmic cities home to billions of stars, each with their own tales to tell. These aren't mere cities in the conventional sense, but colossal celestial bodies we call galaxies. Galaxies, with their immense clusters of stars, interstellar gas, dust, and dark matter, are the cosmic neighborhoods where stars live, die, and are reborn. Let's start with our home galaxy, the Milky Way. It's a beautiful, spiraling mass of about 200 billion stars, including our sun. It's so large that light, traveling at an astonishing speed of 186,000 miles per second, takes 100,000 years to cross it. Now that's a neighborhood you wouldn't want to get lost in. But the universe doesn't stop at our doorstep. There's an incredible diversity of galaxies out there. Take spiral galaxies, for instance. These are flat, rotating disks of stars and interstellar matter, with a bulging center. They're like cosmic pinwheels spinning in the vast expanse of space. Then there are elliptical galaxies. These are more like giant cosmic footballs, with stars distributed more or less evenly throughout. They range from nearly spherical to highly elongated shapes and are typically composed of older stars. And let's not forget the irregular galaxies, the cosmic rebels that refuse to fit into any neat category. These galaxies lack a distinct shape and have chaotic appearances due to the gravitational pull of their larger neighbors or collisions with other galaxies. Living in one of the many cosmic cities, we have a lot more neighbors than we can fathom. Each galaxy is a testament to the universe's age, diversity, and sheer grandeur. They remind us that we are but tiny specks in a vast cosmic ocean, yet connected to the universe in profound ways. So the next time you look up at the night sky, remember, you're not just looking at stars, but distant galaxies, each with a tale as old as time itself. Oh, what if I told you, there are objects in the universe so dense, nothing can escape their gravitational pull, not even light. Yes, we're talking about the enigmatic entities known as black holes. They are like the universe's top secret agents, hidden in the shadows, yet exerting an undeniable influence. Black holes form from the remnants of giant stars that have collapsed under their own gravity after exhausting their nuclear fuel. This collapse results in a singularity, a point of infinite density which forms the heart of the black hole. It's like taking a star 10 times larger than our sun and squeezing it down to the size of a small city. Now let's talk about one of the most intriguing aspects of a black hole, the event horizon. This is the point of no return. Once crossed, nothing can escape the black hole's gravitational grip. It's like an invisible boundary marking the point where our conventional understanding of physics simply breaks down. As you get closer to a black hole, the immense gravitational field starts to pull more on the part of you that's closer to the black hole than the part that's further away. This differential pull is called tidal force, and it's extreme near black holes. It's so extreme, in fact, that it could stretch you out like a piece of spaghetti if you were unlucky enough to fall into one, a process that's been affectionately termed spaghettification. Yet, despite their ominous presence, black holes are crucial to our understanding of the universe. They challenge our comprehension of physics, provoke our curiosity, and invite us to explore the unknown. We may not have all the answers, but isn't that what makes the pursuit of knowledge so exciting? So, the next time you gaze up at the night sky, spare a thought for these cosmic mysteries, these black holes that lie hidden among the stars. Their existence is a reminder of the universe's infinite complexity and our eternal quest to unravel its secrets. Black holes, a riddle that even light cannot solve. In the vast darkness of space, there are regions filled with vibrant colors and gases, the birthplaces of stars. These are no ordinary birthplaces, but rather, they are the grand and beautiful nebulas, cosmic nurseries where stars are born and where they end their lives. These nebulas, vast cloud-like structures, are composed primarily of dust and gas. They are the very essence of the cosmic soup, the raw materials from which stars and planets are formed. They are scattered across the universe, each one unique in its shape, size, and color. Now let's delve into the different types of nebulas. First, we have the emission nebulas. These are the ones that you might recognize from stunning space images. They emit light because they are hot enough to ionize their own gas, creating a glow that often appears red. Next, we have reflection nebulas. These don't emit their own light. Instead, they reflect the light of nearby stars. Imagine them as cosmic mirrors, bouncing off the starlight and creating a spectacular light show. Then there are the dark nebulas. These are the true enigmas of the universe. They are so dense and thick with dust that they block the light from whatever is behind them. They are the unseen, the shadowy figures lurking in the cosmos. Finally, we have the planetary nebulas. Despite their name, they have nothing to do with planets. In truth, these are the remnants of a star's final stages. When a star like our sun reaches the end of its life, it expels its outer layers, forming a planetary nebula. These different types of nebulas play a crucial role in the life cycle of stars. They provide the raw materials for star formation, and in the end, they house the remnants of dead stars. They are the cradles and the graves of stars, the birth and death within the cosmic cycle. Nebulas, the cradles of stars, adding color to the cosmic canvas. They are the artistry of the universe, painting the vast darkness with their vibrant colors and intricate structures. They are a testament to the cycle of life and death that continues to unfold across the cosmos, a cycle that, in many ways, is not so different from our own. From the tiniest atom to the vast cosmos, everything seems to be part of a grand design, but who or what is the architect? The shape of the universe, its fate, and the concept of multiverses are topics that have intrigued scientists for centuries. Among the many theories, one suggests that the universe is flat, extending infinitely in all directions. Others propose a spherical universe, finite yet unbounded, much like the surface of a balloon. As for the fate of the universe, the possibilities are numerous. It might keep expanding forever, or perhaps at some point the expansion might slow down and reverse, leading to a cosmic crunch. Then, there is the tantalizing concept of the multiverse. Picture this. Our universe, with its billions of galaxies, might be just one among an infinite number of universes, each with its own laws of physics. Sounds like science fiction, doesn't it? Yet, some physicists believe this could be the reality, even though we may never be able to prove it. The architect of this grand design remains unknown. Is it a divine being, a cosmic computer, or simply the result of natural laws and processes? We don't know, and perhaps we may never know. What we do know is that the universe is a fascinating, complex, and beautiful place, full of mysteries that we are just beginning to explore. Scientists are using powerful telescopes, sophisticated instruments, and innovative theories to probe the depths of the universe and uncover its secrets. They are studying distant galaxies, observing black holes, exploring colorful nebulas, and searching for signs of life beyond Earth. Each discovery brings us a step closer to understanding our place in the universe and the laws that govern it. As we continue to unravel the secrets of the universe, we realize our journey has just begun.